Good day, everyone. I'm here to discuss the first classical method, which is the double integration method, or also known as DIM. So, what is DIM? The double integration method is an analytical approach wherein the equation of the deflection would be established from the moment equation by integrating it twice, hence to where the method got its name. So, it is also a common method in the field of civil engineering due to the fact that this method is used to obtain the deflection and slope of a beam equation by integrating the moment equation twice, as I said earlier. So, to get the formula for this, the formula for the moment equation is derived from the basic differential equations of elastic curve. If you want a detailed information about this, you can go to chapter 9.2 of Fundamentals of Structures of Leet et al. So, here's the formula for the moment equation. So, moment equation of the beam is expressed as EIY double prime equals to M. So, if you integrate this once, you will get the slope equation. So, it is expressed as EIY prime is equals to integration of M dx plus C1. If you integrate the moment equation twice, you will get the deflection of the beam, and it is expressed as EIY double integration M dx plus C1x plus C2. So again, to summarize the formulas of DIM, EIY double prime, it is the moment equation. EIY prime, it is a slope equation. And EIY, it is a deflection equation. So if you integrate the moment equation, you can get the slope equation, and if you integrate the moment equation twice, you can get the deflection equation. So moment equation uh, can be derived from taking a moment about a cutting plane. Also, take note that the number of segments depend on EI and supports. So now let's go to boundary conditions in solving the arbitrary constant of integration. Here, at the fixed support, di ba? Fixed support yan. At the fixed support, y prime or the slope equation is equals to 0 or the slope. Um, y is equals to 0. So yung deflection is equals to 0 daw. So at the maximum deflection, this one, y prime should not be equal to 0 and y is equals to y max. Next is at a hinge support. This one, yung sa hinge support daw, y prime should not be equal to 0 and y is equals to 0. At the maximum deflection, this one sa gitna, yung maximum deflection niya, y prime is equals to 0 and y is equals to y max. So, at a roller support, same lang siya sa hinge support. Y prime is equals to 0 and y is equal to 0. So, now let's go to the sign convention for DIM. So, yung sign convention dito sa DIM, nakadepende siya kung saan mo sinet up yung origin mo. So, for this one, from left to right, clockwise is positive. Dito yung origin mo, dito ka magmo-moment. So, left to right siya. So, clockwise positive. And the other one is vice versa. If from right to left, counterclockwise, positive naman. Kapag dito ka nag-origin, tapos dito ka nag-moment. So, ang counterclockwise niya is positive. So, for the sign convention for the slope naman, if x is going to the right, ang positive theta is counterclockwise and negative theta is clockwise. And if x is going to left, positive theta is counterclockwise and negative theta is counterclockwise. So that's all for the concepts of DIM. To further understand, let's go to the sample problems. So now, let's go to the sample problem to further understand the topic. So, sample problem. Derive the general equation of the beam and the external support reaction using DIM. Calculate for the following: vertical reaction at A, vertical reaction at B, vertical reaction at C, deflection at the midspan of segment AB, and slope at 5 meters from right of C. So let's continue. So now, for our first step, check the degree of indeterminacy. But before we check that, let's identify first the support reaction. So we have VA at point A, VB at point B, and VC. So let's check the degree of indeterminacy. So the formula for that is number of unknowns minus equilibrium equations. So we have three unknowns, the VA, VB, and VC. And we have two equilibrium equations, the summation forces vertical and the summation moment. So DI is equals to 1. For step 2, set up an origin of X distance on each segment. So magsiset up tayo ng X for segment AB and segment BC. So for AB, ito yung sinat natin. Origin at A and magmo-moment tayo dito. So, for this one, ang origin natin is at C. Ang next na gagawin natin is mag-i-extend natin yung triangle hanggang dun sa line ng imo-moment. Yan. So, since nagdagdag tayo dyan, magdadagdag tayo ng force pataas kasi pababa to, di ba? So, magdadagdag tayo ng force pataas. So, let's call this line na y1 for the height of the triangle. And let's call this y2. Since alam natin na itong rectangle na to na dinagdag natin, yung square na yan, is 15 kn. Ang hindi na lang natin alam is yung y2. So, let's identify y2. So, next, in expressing y in terms of x, let's use ratio and proportion to get y1 and y2. So, y1, ito, height y1 over x, yung base, is equals to 15. Oh, this is 15 though. This is 15 kn. Sorry. Wait, this is 15 kn per m. This is 15 kn per m. So next, y1 over x is equals to 15 times over base, which is 2.5. So we will get y1 is equals to 6x. So next, let's get y2 naman. Itong small triangle equals tong triangle na to. So y2 is equals to x minus 2.5. X minus 2.5 yan kasi ito. Ano yung length na yan? So, this is 2.5. This is x. So, x minus 2.5 will get the length of the small triangle. So, y2 over x minus 2.5 equals 15, this one, and yung base, which is 2.5. So, we will get y2 is equals to 6 times x minus 2.5. So, now let's go to step 3. Which is formulate the moment equation for each segment and integrate 2 times. So, we will use the concept na diniscuss natin earlier for this, yung mga formula. So, now, for span, let's start with span AB. So, EIY double prime is equals to ano yung mga forces sa side na to. We have VAX na pataas, di ba? Na clockwise. So, we will have VA times yung distance, which is x, we will have VAX. Then, ang next natin gagawin is yung rectangular load naman. So, we have 8 times x, kasi i-moment natin sa line na to eh. So, 8 times x times yung centroid niya, yung moment arm, yung distance niya to the moment line. So, we have 8 times x over 2. So, we will integrate it 2 times VAX. So, magiging VAX squared over 2. And yung negative 8x times x over 2 natin, magiging 4x cubed over 3 and plus C1. Don't forget, plus C1 pag nag-integrate. So, we will integrate the moment equation 2 times. We will get EIY is equals to VAX cubed over 6 minus 4x raised to 4 over 12 plus C1x plus C2. Okay? So, next, let's formulate the moment equation na rin for the right side. Okay? So, for span BC, 2EIY. So, non-prismatic yung beam natin, di ba? So, at segment AB, we have EI. At segment BC, we have 2EI. So, we have to modify it then. So, we will divide the moment equation dun sa EI natin. So, but first, let's get the moment equation first before we divide it by 2. So, next, we have VC here na counterclockwise, so it's positive. So, VCX, VC times yung distance. Next is, etong triangle na to. So, we have 1/2 times yung y1 natin, which is 6x kanina, yung kanina natin kinuha. And then, times yung distance pa, don't forget, iba pa yung y1 lang yung 6x. So, times x, times yung yung centroid niya, yung distance niya to moment line. So, x over 3 kasi 1 over 3 times yung distance. So, x over 3. Plus, since nagdagdag tayo dito, meron pa rin tayong force na nasa baba. So, it's a trapezoidal load. So, pwede natin siyang gawing square or rectangle. And triangle. Paghihiwalayin na lang natin siya. So, first, unahin natin tong rectangular na to. So, 15. Kasi we know that this is 15, right? Kasi pag 15. So, 15 times yung length niya, which is x minus 2.5. Kasi, di ba, this is 2.5 and this is x. So, this is x minus 2.5 times yung moment arm, which is x minus 2.5 over 2. So, next naman natin is yung triangular. So, 1/2 times y2. Ang y2 natin, remember, 6 times x minus 2.5. So, ito yan. Ano pa lang natin? Height pa lang yan. Tapos, yung base natin, which is x minus 2.5, times yung centroid natin or moment arm, yung distance natin sa moment line. So, 1/3 times x minus 2.5. So, i-simplify muna natin to and let's modify. I-divide natin siya by 2 kasi we have 2EI. So, we will get VCX over 2 minus x cubed over 2 plus 7.5 times x minus 2.5 raised to 2 over 2 plus x minus 2.5 raised to 3 over 2. So, now let's integrate it to get the slope equation. So, we will get this form. Yung VEC x squared over 4 minus x to the 4th over 8 plus 7.5 times x minus 2.5 raised to 3 over 6 plus x minus 2.5 raised to 4 over 8 plus C3. Don't forget plus C. And now, let's integrate the moment equation twice. So we will get the deflection equation, which is the VC x cubed over 12 minus x raised to 5 over 4 plus 7.5 times x minus 2.5 raised to 4 over 24 plus x minus 2.5 raised to 5 over 40 plus C3x plus C4. So now, we are done in formulating the moment equation. Let's go to step 4. So now, let's go to the step 4, which is observe boundary conditions. So, this is our problem and ito yung boundary condition na dinascuss natin earlier. So, we will use this to formulate equations. So, first, ano bang meron sa span AB? Let's start with span AB, ha? So, sa point A, we have our roller sport. So, we know that y prime should not be equal to 0 and y is equal to 0. So, at A, x is equal to 0 because wala namang distance, and y is equal to 0. Let's substitute from the deflection equation. We will have C2 is equal to 0. So, what else? Ano pa ba? Point B naman tayo. Anong meron? So, at a hinge support daw, y is equals to 0 din. So, let's use that boundary condition. So, at x is equals to 2, kasi in distance, in length, y is equals to 0. So, let's substitute again from the deflection equation. We will get this one. The first equation, which is the 4 over 3 VA minus 2C1 is equals to 16 over 3. So, here, more on substitution na lang tayo. So, we already have our first equation. What else? So, sa hinge support, we know that y prime should not be equal to 0. So, we can have at B, x is equals to 2. And we can use the slope equation and substitute. So, here's the slope equation. Let's substitute. Let's substitute x. So, we will have this one. We will have the slope equation at B. So, but hindi pa yan yung madadagdag sa equations natin. So, what else? Okay, so wala na. So, let's go to span BC. So, sa span BC, we know that at point C, sa hinge support, y is equals to 0 again. So, at x is equals to 0, y is equals to 0 then. So, let's substitute from the deflection equation ng span BC. So, we will get C4 is equals to 0. So, what else? So, at B, pwede natin gawing at B, x is equals to 5 and y is equals to 0 because sa hinge support, y is equals to 0 then. There. So, let's substitute from the deflection equation again. We will get this one, the second equation. So, ito, more on substitution lang yan. Ipasok mo yung 5 dito sa x, dito, and then simplify. So, we get our second equation. So, what else? So, ito, pwede rin at B, x is equals to 5, and we can use the slope equation again. So, here's the slope equation. Let's substitute. Input natin yung x na x is equals to 5. So, we will get the ey prime b, yung slope din sa b. And from here, pwede pa tayo mag-isip ng bagong equation. So, ano pa? We already have 2 equations. Tapos meron din tayong 2 equations from equilibrium. So, we already have 4 equations. But, ilan ba yung unknowns natin? Kasi, hindi, may 3 unknowns na tayo. Pero, kasama pa si C1 at si C3. So, we have 5 unknowns. So, we need to look for 5 equations. May dalawa na tayo. Meron pa tayo sa equilibrium. So, kailangan pa natin ng isa. We can get that equation from here. So, let's draw the elastic curve kasi medyo mas complicated to kesa dun sa ibang boundary condition. So, I'll show you. So, here, we can say that our elastic curve here is pag ganito. Pag ganyan. Diba? Yan. Okay. So, ito yung beam natin. So, makikita natin na yung slope dito sa segment AB and yung slope dito sa kabilang segment, sa BC, is the same. So, pwede natin i-equate yung dalawang equation na formulate natin from the boundary condition, and we can have our third equation. But here, so let's go here na lang. Yan. So let's draw it first again para makita nyo. So ito ang tsura ng elastic curve. So we know, ito yung beam. Sorry. Here, yan. So, makikita natin na yung y prime b natin, wait lang, yung y prime b natin ng segment AB is equal sa y prime b ng segment BC. So, ayan. But, magiging negative yung sa segment BC. Kasi, if titingnan mo, nasa left side siya. So, from left to right, yung sign convention natin is pa-counterclockwise siya. So, magiging negative yung y prime b natin sa segment BC. Okay? So, this is B. This is segment BC. And this one is segment BA. Okay. So, now, equate natin sila. Okay. So, we will have 2VA plus C1 minus 32 over 3 is equals to close and open parentheses, negative 25 over 4 VC minus 6875 over 28 plus C3. We got this from the boundary condition na finormulate natin kanina sa segment AB and segment BC. In-equate lang natin siya since nakita nga natin doon sa elastic curve na same slope siya. So now, let's simplify the equation. There. So, we will have 2VA plus 25 over 4VC plus C1 plus C3 equals 24721 over 384 as our third equation. So, we already have three equations. So now, let's go to the next step. So, now let's go to the next step, which is equilibrium equations. We're going to formulate equilibrium equations kasi we already have three equations from the boundary conditions na nakuha natin kanina. So, next is yung equilibrium equation naman, yung dalawang equilibrium equation. So, now, let's start. So, this is 15 kNm. I'm sorry. Okay? So, now, let's start. Saan tayo ngayon magmo-moment? So, I advise na mag-moment tayo for this specific problem sa point B para hindi naman nagdagan yung unknowns natin. Kasi kapag nag-moment tayo sa C or sa A, magkakaroon ng VB. Eh, from our previous equations, wala tayong VB. Okay? So, let's start. Summation moment at B is equals to 0. Let's get first the VA. So, VA times 2, it's clockwise, so it's positive. Next is yung rectangular load na 8 kN per meter. So, 8 times yung length, which is 2, times yung centroid niya to, yung distance centroid niya to B, which is 2 over 2. Next, let's get the triangular load naman. So, 1/2 times 15 times 2.5, the length, and times the distance of the centroid to point B. So, 1/3 ng 2.5, the centroid, plus yung distance pa, which is 2.5. So, plus 2.5. And lastly, the VC. So, we have VC times 5. It's negative because it's counterclockwise. So, simplifying the equation, we will have 2VA minus 5VC equals negative 93 over 2. We already have our 4 equations. From here, we can already get the we can already use the 4 equations for unknowns. So, mamaya na natin formulate yung summation forces vertical para diretso natin makuha yung VB later. So, first, let's solve simultaneously.
So now, let's solve simultaneously. So for the first equation, we have 4 over 3 VA. And then, we don't have VC. So, ang gawin natin is A is equals to VA, B is equals to VB, C is equals to C1, D is equals to C2. So, okay, let's continue. So, we don't have VA, so 0, plus 2C1, so we have 2C1, and we don't have C3. So, here, equals 16 over 3. Next is, for the second equation, we don't have VA, and then 125 over 12 VC, and then we don't have C1, and then 5C3, so positive 5C3, and then 8 to 1 equals 8 to 1 to 5 over 128. So for the third equation, we have 2VA, positive 25 over 4 VC, plus C1, plus C2, C3, sorry. And then, we have equals 2, 4, 7, 2, 1, 2, 4, 7, 2, 1 over 3, 8, 4. And then, next is we have 2VA, negative 5VC, we don't have C1 and C3, and then equals negative 93 over 2. And then, we get VA is equals to 3.4219. VC is equals to 10. So now, let's solve simultaneously. So for the first equation, we have 4 over 3 VA. And then, we don't have VC. So, ang gawin natin is,
So, from here, yung sa nakuha nating values, we can now get VB from formulating one equilibrium equation pa, which is the summation forces vertical. So now, summation f of y is equals to 0. We have yung VA, pataas na VA, pataas na VB, so positive din, and VC. Meron pa tayong rectangular load and triangular load. So, since mababa siya, negative 8 times 2 and negative 1/2 times 15 times 2.5 is equals to 0. So, let's simplify the equation and substitute the VA and VC na nakuha natin kanina sa 4 equations for unknowns. So, here, we will get VB. And VB is 20.6593. Okay, so next, we already get the vertical reactions at A, B, and C. Now, let's proceed to the next question. So, next is the deflection. We will get the deflection at the midspan of segment AB. So, ang length ng segment AB natin is 2. Pero midspan, so we will use at x is equals to 1. So at x is equals to 1, let's substitute it from the deflection equation. So substitute natin yung x doon. And then we will have 3.4291 times 1 raised to 3 over 6 minus 4 times 1 raised to 4 over 12 plus 0.3854 times 1 plus 0. So, yung values na yan, nakuha natin kanina dun sa Finoor equations for unknowns natin. Okay? From there, we can get the deflection at the midspan of segment AB, which is y is equals to 0.06224 over EI. Don't forget EI, ha? Okay? So, next, we already solved the four questions. And lastly, so now, let's go to the last question, which is slope at 5 meters from the right of C. So, we're going to use at B, x is equals to 5. Then, we're going to substitute it sa slope equation na formulate natin kanina sa segment BC. And then, okay, substitute. Then yung VC, and yung C3, nakuha natin siya kanina sa 4 equations for unknowns. So, kompleto na. So solving this, we will have 42.5003 over EI. So, we're done. For the slope, we have y prime is equals to 42.5003 EI. We're done with this topic. I hope you learned something from it. So thank you for listening, guys, and I hope you learned something from me. If you want to check the answers, you can use other classical methods like AMM, CBM for checking your answers. Thank you.